Alright, so hello and welcome. Here we are another day. It's going to be a few seconds to make sure the live stream is working, the audio is working. Let's see. A few more moments. Let's see. Hello, hello, hello. Hey, it's working. Very good. Okay. Oh, excuse me. Oh, man. Some days are tough. Some days are tough. Okay. Let's work on this. I think I'm good to go. So, maximum length of a concatenated string with unique characters. Let's go. Let's do that. Yeah, I'm not going to go into too much detail about what's so difficult, but just say war is hell, right? War is hell. Let's go with that. Not always a bad thing though. War is not always a bad thing, but it's definitely can be rough. Okay, pretty high submission rate and acceptance rate, so this probably is not that hard. Maximum length of a concatenated string with unique characters. Yeah. You are given an array of strings or ARR. A string S is formed by the concatenation of a subsequence of array that has unique characters. Return the maximum possible length of S. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay. Excuse me. Concatenation of a subsequence of array that has unique characters. Return the maximum possible length of S. Okay, interesting. So it's just the maximum possible length of a subsequence that has unique characters. Oh, excuse me. An array of strings. Oh, it's not one string, it's a few strings. All the valid concatenations are maximum length is 4. Oh. Huh. Interesting. Array length is between 1 and 16. Contains only lowercase English letters. Each array has at most 26 letters. I think this could be done. I mean, you could just go through all the subsequences. That's not subsequence, really subsets is what it is. All the possible subsets, which there's only 2 to the 16th is only about 65,000 subsets. Excuse me. Okay, I'm not sure what to make of this exactly. You could go through all the possible subsets and then just filter out the ones that have unique characters, and also filter out the ones that have unique characters, and then also just get the largest size of those. Excuse me, I mean, you could do it that way. It's not really, not really good. It's probably fast enough. I mean, you could use a frequency map for each string to make things a little more efficient, a little bit more efficient. Yeah. Excuse me. I mean, it's one way of doing things. Is there a faster way to do this? Backtracking maybe? Algorithm X. Knuth's algorithm X. Excuse me. It's a good question to see if there's a faster way to do this or not. Tempted to try a backtracking solution. Excuse me. I'm also tempted to just try to see if you can get each number. So if it's possible to get at least 1, and then 2 and 3 and so on. Because 26 is not that many. Like there aren't that many unique characters to deal with. Which is why I'm wondering if, I'm pretty sure there's a much faster way to do this. Very fast way to do it, because 26 is very small. All these numbers are really small. 16, 26, 26. Like this is pretty. I feel like even if you brute force, like well, basically, yeah. Even if you brute force this, it's gonna be pretty quick. But I think you could do it even like you don't have to brute force it. I think you could do a slightly more clever approach that's very fast. Excuse me, I'm not sure exactly how I might want to do that. Let's see. Let's see. Forgive me, sir, my mind has been wandering lately. It's like I'm having a hard time staying focused. Maximum possible length, this. You know, this is very similar to the vertex cover problem. It's not the same, but it's, excuse me, subset cover problem. That's what I'm thinking of. But it's not really a subset cover problem. It's a little bit slightly different. It's a little different. It's like a 0-1 knapsack problem, something like that. Something like that. Also, what is going on? Oh boy. I didn't realize my frames are dropping. Gee, okay. That's weird. Thinking of the 0, 1 knapsack problem is kind of what I'm thinking. Common problem being solved is a 0, 1 knapsack problem, which restricts the number x sub I, copies of each kind of item to 0, 1. Given a set of n items numbered 1 to n, each with a weight. No, this isn't quite what I'm looking for. No. No. Not what I'm looking for. I'm trying to think of a clever way to do this. I don't have any good ones. I don't know. I don't know. I'm very tempted to just go through walk through all the possibilities. You know what this is similar to? This is very similar to the subset cover problem, right? The subset cover problem. Subset cover. This is very similar to the subset cover problem, but it's different from, there's the exact cover. Yeah. Given a collection of subsets, the basic example. Subcollection OE is an exact cover of X. Yeah. So it's not looking for it's looking for the largest cover. Not the exact cover though. Although the cover itself is of disjoint. It's the maximal cover, disjoint cover. Yeah. This is I think this is NP complete. Okay. Exact cover problem is NP complete. So the problem I'm looking at right now, I don't think is NP complete though. It's similar. Largest set of non-overlapping geometric shapes. Both are NP complete. Maximum independent set. It's similar. It's still not quite. It's not quite the same. I don't know what this is called. I'm pretty sure this falls into one of these categories though. This is similar to I don't know what to call this. But it's very similar to these NP complete problems. It's somewhere, it's either NP complete itself or it's just very similar. Very similar. I suspect it is NP complete. Suspect that it is NP complete. Optimization search version. Okay, what I want is the largest union of independent sets. I should learn integer programming. Really, that would help a lot with a lot of these problems. I think. I think so. Huh. Do LP relaxation. Huh. Log-in factor approximation. Weighted set cover. Fractional set cover. What about a weighted set cover or exact set cover abduction? I don't get all that. Another one worth looking at. Okay. Pretty sure this question is a constraint satisfaction problem. I would need to reduce it to another question that's NP complete to say it's NP complete. I don't know. I don't know. Part of me thinks this is easier than I realize though. Like if I just go, one at a time, right? Like is it possible to get one? It's possible to get two, so it's possible to get one. It's possible to get two. Yeah, it's already possible to get two. Is it possible to get three? Yeah, you can get 3 and 4. Is it possible to get 5? You would need all 3, which is not possible. You can't get 5. Anything more than 5, you can't get. Well, 5, 6, 7, etc. Yeah, it would be impossible. You could just go through them one by one. It's possible to get 1, 2, and 3, 4, 6. I mean, gee. Whoa. This one just goes straight to 26. Excuse me. Gotta wonder. I have got to wonder about this. Maybe I should just program the brute force solution and move on. You know, maybe I should. It's definitely easier if I do that. Definitely easier if I do that. I'm tempted to do that. That would be pretty quick. Fast to program. What else can I do? Could consider these numbers to be. Consider these letters to be numbers from 0 to 25 inclusive. And then you could say, yeah, you're looking for the largest union of disjoint sets. And it's not the largest union of set, each set would have some weight to it, right? Or something like that. Like it's. Yeah, the largest sized union of disjoints. Yeah, that's right. No, that's correct. Excuse me. I don't know that one offhand. If it's not just a brute force approach, then I don't know it offhand. I have to sit and think about it for a while, I think. Suddenly just getting very tired. I don't just want to brute force it. That seems bad. But maybe it's the only way. Excuse me. Excuse me. Maybe largest cover. How about that one? If I find out this is MP complete, then I can kind of relax a little bit. Maximum coverage. NP hard. Okay. One minus one over E. Essentially the best possible polynomial time approximation algorithm. Wow. I was gonna say, I was like, greedy algorithm? It's pretty amazing. We'll come back to that. Let's do the maximum coverage problem. Maximum independent cover problem. Or, yeah, disjoint. Maybe this is a set packing question. Yeah, this is what I want. Thin covering, set packing. I'm looking for hypergraph matching. 1-to-1 polynomial time reduction between them, independent set problem. It's not the independent set that I'm looking for. It's not quite that. It's a little bit different. Set cover, exact cover. This is. I know it's something related to one of these. I'm sure. All right. It's like very likely. I'm just gonna go with the brute force solution. Keep it simple. Just keep it simple, not spend so much time doing these things. Let's do M and N. Yeah, M less than M. And I'm gonna say if bit and I. Then I'm gonna take frequency. Or just like current. Then we're gonna go through current of index, then break. Set j equal to m, and break here and break here. Otherwise, set current of index equal to true. And something like the following. Yeah, something like this. How are we doing on time? 35 minutes? I suppose I could have programmed this sooner. Oh no. I got 12, it should be 11. Really? Uh-oh. Oh. Oh, this should be skipped in this case. Maybe we could just. Maybe that's the reason. I think it has something to do with it too. Maybe that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm gonna go for it. It could be wrong. Could be missing some things. Oh, it's right. Okay. Alright. I was gonna do this first. I was like, this is like simple enough. Could do it like this. It's fine. Pretty straightforward. Maybe not the fastest solution, but it's reasonable. Let's go for a few more submissions. Yeah, I don't know if it's worth wasting so much time thinking about questions like this, where it's like you could sit around pondering like faster ways to do this, but do you really need to? Is it really worth the time? Is it really worth it? Yeah. Recursion memoization. Let's do the most votes. Set solution, DFS, bit and set operations. Bit masking, clean and concise. That's what I have here. It's just the bit set, bit masks. Although it's kind of slow. It's not 0 milliseconds. Thinking. Oh. I should probably convert the the substrings themselves to integers to bit masks. Oh, that's a good idea. It's a better idea. I like that. I like that. Let's do that. Actually. That's a good idea. Oops. Yeah. And then I can do so I don't need to do this anymore. I can do if current if not current and masks J, if not check, or if check, then I do one thing otherwise, or equal with this mask. Here we would say J equals M, skip equals true, break. That might be something cleaner that they did. The other solutions could have looked more like this. Could have looked more like this. Oh. The number of bits in current. It's like pop count, right? Underscore underscore built-in underscore pop count. Yeah. Just out of what do you call that? Just might as well try that. Wrong answer. 16 should be 1. Okay. Just I think replace it with a 0. Just do a check also, I think. That's the bit. Check is going to be result and this bit. If check is true, then return 0. Otherwise, or equal with this bit. Yeah, meaning you have to throw out the ones that have multiple. Could try this one. See if it works. There we go. That's faster. That's a lot faster. Okay. Yeah, that's worth doing. That's worth trying. Yeah, it's just because some of the strings have duplicate, right? They don't say whether or not the array has only unique characters in the strings. Doesn't say that. Yeah, the bit mask you can because there's only 26 characters, and you only care about unique values. Could just use bit masks in this way. Also, the built-in pop count makes it a little bit easier to do this as well. This is pretty straightforward. This part's kind of tricky. You might be able to optimize this a little bit more. Even so, 10 milliseconds is still probably longer than it should be. But this is okay. I mean, this is fine. You really don't have to get too crazy with this. This is really, it's either way, it's like just a brute force solution. It's not, apparently there's a way to use the bit mask to make it even cleaner. Let's see. What else can I do? Could I have done? Exponential. Okay. 100% in C++. First throw away all strings that are duplicate characters. Oh, you know what? That's a good call. I didn't think about that. Also, vector bit sets. Oh, you could use bit sets for this. That's a good idea. Oh no. I didn't even think about that. Oh, that's a good idea, actually. Hold on. Wait a second. That's a good idea. I have an idea. Get the, forget that. Forget using the transform algorithm routine. Okay, I think this works. We actually just return altogether. Oh, no, not return. Break. Continue. Okay. Result or equals the bit. Yeah. The reason why I would want to do it this way is because now I can say m and n. M is masks.size, and n is. If I just outright remove those, it should make things a little bit faster. There we go. Oh no. Okay. We do it on time. All right, let me go for it. Go for it. This could be wrong. Nope. No, not much faster. About the same as the other one. Okay. Doesn't actually save me much. Okay. All right, what did the other guy do? What did the other guy do? Let me run this one again. I thought that was the only difference, really, but I guess not. Maybe because he used bit sets. That could be it. A little more efficient. Oh wow, whoa. 8 milliseconds, pretty fast. It could be, bin.set. Oh, you could just check the count against this. Oh, that's good. That's a good idea. That helps. Okay. Concat. Empty concatenation and iteratively increase its length by trying to add more strings. Why doesn't it use the curly braces for the for loops? That's very clean. Reverse traversing the concat. Code blocks in tabular form. If your for statement doesn't, if it's only one statement, you don't need the braces. Which technically it is one statement. This is not one statement, so it has braces. But the if statement is one statement, which is kind of funny. It's kind of funny. This is clever. I like this. I didn't really think about that. And then, so I just used bit sets. Okay, that works. It's a little bit more efficient to use bit sets also. Although, no, not really. I mean, no, I don't know. Maybe it's, I don't know. The vector of bit sets. Okay, empty bit set. Unique. So for each of these. So how did he do this? He went with each string concat size. This is none. And concat. What is this? He did it in a way that's really odd to me. I didn't do it like this at all. So unique bit sets first, that's fine. Start with an empty concatenation and iteratively increase its length by trying to add more strings. Oh, okay, that makes sense. So he basically used a breadth first level order traversal. Yeah, it's a little different. I mean that works too. Yeah. Interesting. That's another way of doing it. Oops. I didn't do it that way. That's maybe a little bit easier than this way. That's a little bit more efficient to do it like that. Yeah, that's fair. That's fair. You could do it that way too. All right. So what it looks like is, let's use bit sets. So I liked how he did it with the bit sets. That was pretty good. That was pretty good. Excuse me. I think he sets it. Okay. And then the next one is we have the level, more or less. Level. And this is just going to be initially single empty bit set. And we're going to say const auto. Well, yeah. Auto current in current bit set in the level. Or not the level, we could do. I mean, there are multiple ways to do a level order traversal. I usually do like 2 levels where you push one into the next one, but you could just do each mask, and then for each mask, if you were going to do it this way, you would want to go backwards through the level. Like he did it, and the reason why you'd want to do that, set, or let's do current mask and just current. I don't know what I would call this. Current bit set, current possibility or something. And what you're going to do is you're going to say this, the current possibility and the current mask. If I don't know all the bit set, I don't know what the bit set operations you used were, but if it's not, in other words, if they don't overlap, you know, it's equal to 0 or something like that, then you can, you know, do the rest. Otherwise, you skip it. Yeah, what did he use? He used like none or something or other. I don't know the bit set operations offhand. Can you AND them? Oh, you can. Yeah, you can just AND them. That's cool. Yeah. So you're gonna AND them, and if it's dot none, then what you can do is add so new bit set, and then I can say level.pushback new bit set, and also I could take the result and just I think it's count, right? Size. Count. Okay, that's what I want, is count. Something like this. Let me try this one. Keep losing my test cases, man. Keep losing my test cases. File error, of course. What was the file error? Set. Oh. Set. Try that. This is probably standard size. Standard size T. I'm gonna go for it. Go for it. That's faster. That's quite a bit faster. Yeah, there's more than one way to do this. Okay. That makes sense. Yeah, you don't have as many like operations you need to go through if you do it this way. Yeah, this is an interesting way of looking at it, doing it. I probably should have thought of this first, actually. Now that I'm thinking about it a little more. This is better. For various reasons. Number one, it's faster. Number two, it's cleaner. It's faster, it's cleaner, easier to code, simpler. 1002, 1003, 1004, 1005. Yeah, I mean this is just again, these are all just brute force solutions ultimately. Where did it go? Yeah. Someone in the comments said that it was brilliant that he was going backwards through the level. It's not that crazy to do that. Some problems you can do it that way. Some problems it's not really. Some problems, like it depends what the problem is when you're doing your. It's like a DP solution type of thing, DP technique. There's different variations on that. Like some cases, you want to calculate the next set of elements, and you want to throw out the previous set. So you've got to swap the buffers. Sometimes you got to do a buffer swap. You could do that too. You could do if you did a buffer swap here, you wouldn't have to go backwards. But sometimes you can save even the buffer swap if you want to keep the previous set of elements, which we want in this case. keep the previous set of elements, and include the new set of elements, you can go backwards and avoid the buffer swap altogether. And the reason why you go backwards is because if you go forwards, then the new element you just added is going to be counted a second. It's going to be, as soon as you add that new element, you're going to try to iterate again on that element. This particular problem, you actually don't need to go backwards. You could go forwards if you wanted to. It should still give you the right answer. It's just, it's less efficient if you do it that way. The way this problem works out. Actually, yeah, this should be fine. I think this still works. It's slower though. Let's see if it still works. Yeah, it's just slower. The reason it still works is because of this if statement. You're basically taking something you just added and trying to add it again. It just won't create the new. Even if you process it a second time, it won't create the new thing. So you don't actually need this. You don't need to worry about that. It's kind of unique to this question that you actually don't even need to go backwards. Just the way that it works, the way that it operates. But other questions, it would actually break your solution. Oh, I guess we're just at 3 milliseconds now. But yeah, you don't actually even need to go backwards, which is pretty funny. That's a subtle thing. 1, 2, 3, 4, 5. So yeah, not even that clever, actually. Not even that clever. But good still. I mean, again, it depends on the algorithm and the DP you're doing. This is a kind of a DP sort of thing. Level loader DP. I've done the similar thing a few times on stream. A few times before. Yeah, this is definitely good. I mean, I like the count that you can count easily. This is easier than going through all of the. What makes this a little more unique is this kind of reminds me of when you count the number of subsets in a power set. If you're going to generate all the subsets of a power set, you could do it this way, where you add each element to all of the values you've already seen, sets you've already seen. That's kind of what this is doing. It's basically running through the same kind of algorithm, which I have a tendency to forget that you can do it this way. You can go element by element and just take all of the sets you have currently, starting with an empty set, and then keep the empty set and add this element to that set. So now you have the empty set and an element in your set. Then take those two sets and do the same thing again. So now you have an empty set, two elements combined, and then one element, and then on, right? That'll give you all of the power sets. So this is another way of iterating through power sets. What makes this really clever, though, is that this if statement actually filters a lot of the power sets out that you might be considering. Filters them out early on. That's a pretty clever way of doing it. But yeah, that's the other way of iterating through power sets is the one that I had before, which is obviously quite a bit slower. Which I don't know, man. I tend to forget that this is a way to iterate through power sets. I just forget. Just forget. I've seen it so many times now too, and every time I see it, I always I'm annoyed because I'm like, oh, I forgot you could do it that way. I forgot you could do it that way. Yeah. All right. Well. Okay. So bit sets and the level order power set. DP. Yeah, it's a good question to look at. I mean, it's not. Ultimately, this is still going to be. Excuse me. The solutions are all basically. Like this is kind of like an this is as though you're solving an NP hard question. I don't know if it's actually NP hard, but it's as though you're solving an NP hard question. Which you could use this algorithm for quite a few different, something similar to this for quite a few different, I guess NP hard questions. which is kind of neat. It's not a very efficient algorithm, obviously, but it's if you know the problem would be relatively quick to solve, generally, you could use this. Yeah, I don't know, man. Whenever I see some kind of question that I think is NP hard, I actually didn't prove that this one is. I just think it is. I always just get stuck on it for a while. It just always takes me a while. But it really probably shouldn't. I've seen it so many times, but just I don't know. It takes me a while to code, or it takes me a while to think about it, or I don't see it, or I forget I could do it this way, or whatever. Some I don't know what to say. Variation of those things. Some variation of those things. Very interesting, no less. Very interesting, no less. That was a good solution. Yeah, it's a good one. All right, I'm gonna stop here, I think, for today. I don't really want to spend too much time programming stuff. I just kind of wanted to do one question. I was having kind of a rough day today, and just things that are difficult to contend with, I suppose. So thank you for watching. Talk to you soon. Have a good rest of your day. Like this video if you like it, and subscribe for more. Yeah, I've been like really slowing down lately. I've just been very anxious is what it is. Anxious, frustrated and anxious. Very many difficult things I have to deal with, contend with. Yeah, I mean, I'm just taking it a day at a time, I suppose. You know, you just, I don't know, keep going, keep trying. But yeah, slow day today. Then normally I like to do like 10 or more questions a day. It's pretty good. I'm trying to get through like the last 40 questions before I get to 1,000, and then I think after that I want to take a break, go focus on some more real life things, things outside of LeetCode. But yeah, altogether, all things considered, it's difficult. Just say all things considered, it's difficult, and yeah. Anyway, okay, yeah, that's all personal stuff. I don't want to get into too much detail. I'll just say it's like I think it's okay. You know, I don't know. I look at other people. They're able to put a lot more time in than I am, and it makes me very angry. Actually, not so much that they're able to do these things, but that I'm not able to really bothers me a lot. I get pretty annoyed. There's like so many things I want to work on, but I just don't have the time. And it's very frustrating. It's very frustrating. Also, it's frustrating too. I think it's for other people to understand that is like very hard, because the problem is that it's very difficult for me to like plan things out, because it's just so much uncertainty that I have to deal with. Yeah, and it's just like I have to constantly like like I literally have to like sit and relax. Because it's like that some of the things are just so frustrating. Like I have to just take a few minutes and just be like, all right, just deep breath. Because what happens when you're really emotional is you make really bad decisions typically. And it happens to men too. It's much worse for women, but it happens to men too, where they get frustrated or upset about something, and then like they do something really dumb. Which I've done that before. Absolutely. Absolutely. Not realizing, you know, what I'm being subjected to. Also, that's another part of it. Yeah. Sometimes I feel like a freaking, like a hamster in someone's laboratory or something, that like I'm being poked and prodded by these unseen forces, which I'm starting to see them. Maybe more on that another time, but yeah. Anyway, I'm kind of rambling on about stuff, but yeah, all of this is to say I'm gonna not do too many problems today. Some days I just don't do that many questions, and it's usually because of personal things going on, either positive or negative. But yeah, anyway, all right, I'm gonna go. All right, take care.